Hey guys, welcome back to Chemistry TV. Let's focus on Chemistry online class. And when I talk about Chemistry, I'm talking about higher organic what chemistry course. And our program focus going to be what stereo what isomerism. We are going to talk about identifying chiral carbon and what possible numbers of what stereo what isomers. Now, at this one aspect of what this other what optical what isomerism, optical optical isomerism. Are you there? And optical isomerism occur when a carbon have four different groups. So I've done a complete video when it comes to what optical isomerism. I'll leave the link at the description below where I talk about what's optical isomerism and how to understand what optical isomerism. Do you understand? So molecule that exhibits optical isomerism, they are called chiral what molecule. Do you understand? And the chiral molecule is that molecule that have a chiral what carbon or a chiral what center. So the word now be what is what chiral carbon. Now a chiral carbon is that carbon that have four groups attached to it, four different groups attached to it. It must be what four different groups. So if I have a carbon like this, a carbon that have A, B, C, and D, I there, or let's just say Z and what and Y. Yes, let's use one here. Now, this carbon that carry four different groups is called a chiral what? Chiral what carbon. Like the or a chiral what center. Like there. So a chiral molecule is that molecule that possesses a chiral carbon. So when a molecule contains a chiral carbon, it's called a chiral what molecule. And all chiral molecule is what optical what isomerism. Do you understand? Or it's what optical what isomerism. So now, what I really want to talk about here is that how do you identify a chiral carbon? How do you get a possible stereo what isomers? Right there. Now, to get because the numbers of chiral center determine the numbers of possible stereoisomers that molecule will possess. Do you understand? So we have a simple formula for you to be able to know how to get the numbers of possible stereoisomers a chiral molecule will possess. Do you understand? So we have like when I say we have a simple formula you can use to get the numbers of positive stereoisomers a chiral molecule will possess. And you have numbers of stereoisomers is equal to what? 2 raised by what? N. Idea. 2 raised by what? N. Where N means what? Numbers of chiral what center. Just now. So do what I want to go talk about this video here. I want to teach you how to identify numbers of chiral center. Then how to get what numbers of possible stereoisomers. Just now. So, but if you really want to understand what is called optical isomerism, I've done a complete video on that. You can check out the description below. You can check out the description below so you can go check out that video. So now let's take what the first let's take what the first question. So now let's take this first question here. Now let's take this question here. So that when the following compounds contain a chiral carbon, when the following compound contain a chiral carbon, draw the structure and calculate what the numbers of stereoisomers. Now, whenever I see this kind of question in your exam, it should be an easy question for you. You understand? So here we have A, B, and C. So I will use this one to explain to you so you understand very well. So we have 4 amino, 4 cyano, 3 nitroheptane, and here we have 3 phenyl, 2 butanol, and here we have 3 chloro, 1 butene. So now for you to be able to identify the numbers of chiral center, first of all, you have to draw the structure. So as an organic chemistry student, you should be able to know how to draw organic structure because these are the first chemistry course you are learning. You have actually done introduction to organic chemistry. Do you understand? So that is why you need to take everything step by step. But even with that step, I'm still going to explain for you to understand. So let's get into it here. Here we have 4 amino, 4 cyano, 3 nitroheptane. Now whenever you see something like this here, now the parent chain is always the one that comes last. Heptane, and heptane is what is alkane family, stable carbon atom with all single bond. Do you understand? So now because it's heptane that is stable carbon atom with all single bond, so it's going to be 1, 2, 3, 4, 5, 6, 7. Do you understand? 1, 2, 3, 4, 5, 6, 7. So you can start your number anywhere. 1, 2, 3, 4, 5, 6, and what 7. Do you understand? Now, yeah, so once I've done that here, just because amino and cyno and what nitro, they are what substituents. They are what substituents. They are what side chain that is attached to what the parent what chain, right? So now let's start placing each of them in their what position or in their what position of the carbon atom here. At carbon number 4, I what amino, and amino is what NH2. It's called what amino. At carbon number 4 also have cyno. We so you have CN. It's called cyno. The carbon number 3 have a nitro, so you have nitro. NO2. Do you understand? Like next you want to do here is what next you want to do here is what impute what your hydrogen atom. Understand that carbon should have 4 bonds. Do you understand? And anyway, carbon is not before bond. You have to what place it with hydrogen. Enough for the carbon to have 4 bonds. Do you understand? So this one is already having 1 bond here. It needs what 3 more bonds. And those 3 more bonds are going to be what 3 hydrogen. So it's going to be 1, 2, and what and 3, right? So here we have here going to be 2, 1, and what and 2. Here going to be what 1, 1. Do you understand? Here now here's already complete. Here going to be 2, 1, 2. Here going to be 2, 1, 2. Here going to be what 1, 2, and what 3. Is it okay? So now this is what is structure, and it's called fully display structure. Fully what display was structure. Now next thing we want to do now, we want to identify what the chiral what center or the chiral carbon. And I say that a chiral carbon is that point or carbon that has 4 different groups. So now let's start from here. This is not a chiral carbon. Why? Because this carbon atom have what 4. They have hydrogen, hydrogen, hydrogen. Yeah, but I gave this stuff here. A, B, Y, and what and Z. What does it mean? It means that you like here you have H, Cl, B, R, and what F. Can you see that? This carbon atom here is called a chiral carbon. Why? Because it's having hydrogen, chlorine, fluorine, and what bromine. So any carbon that have 4 different attached to it is called a chiral what carbon. As easy as that. As easy as that. Do you understand? So yeah, it's not a chiral carbon. So the J is already out. It's not a chiral carbon. Why? Because this carbon atom have what 3 hydrogen, right? So it's not a chiral carbon. What about this one here? It's not a chiral carbon here because it have 2 what hydrogen. So it's not a chiral carbon. Right now, this one is a chiral carbon. This one is not a chiral carbon. This is not a chiral carbon. This is not a chiral carbon. So they are all out. You get now. These 2 are called chiral carbon. Why? So if you check this one here, they have hydrogen, NO2. Here we have the whole of this one here as one, as one, and we have the whole of this as one. Do you understand? So this carbon have 4 different groups. So is what is a chiral carbon. So we have steric it. Do you understand? We are taking because this carbon have hydrogen, NO2, this guy and this guy here. They are all different groups. Do you understand? Now if you look at this one here, this one is also a chiral carbon. How is a chiral carbon? Here we have NH2, right? CN, the whole of this one and the whole of this one. Do you understand? So this carbon is what is a chiral what carbon. So in the sense that here we have 2 chiral carbon. 2 what? This compound have what 2 chiral carbon. So number of chiral carbon, which is what N equals to what 2. Right there. So how do you get possible stereoisomers? Numbers of stereoisomers. Numbers of stereoisomers equals to what 2 raised by what N. Right there. 2 raised by N. My N now is what? My N is what is 2. So going to be 2 raised by what 2, which is going to be what 4. Do you understand? It means that 4 amino, 4 cyno, 3 nitroheptane possess 4 possible stereoisomers. That is, you can get 4 possible stereoisomers from here. Do you understand? Now, I'm not going to teach you how to draw isomers, or enantiomers. I'm not going to show you that one in this class here. I'm only teaching you how to identify chiral center and how to get numbers of possible stereoisomers. Do you understand? So that is it for this one here. So this one I have what 4 possible stereoisomers. Do you understand? So please, if you understand the first one, please leave a comment section that you understand the first one, because I'm going to give you one for you to try. It's very important. And when I give you one for you to try, please leave it at the comment section. It's very important. Leave it at the comment section. So let's look at what the P parts. 3 phenyl, 2 butanol. 2 butanol. Butanol, idea, is what? 4 carbon atom with what? OH. Aqua is what? Is an aqua functional group. Do you understand? And the OH is our carbon number what? 2. So but is what? How many carbon atom? 4 carbon atoms. So it will be 1, 2, 3, 4. Idea. And is that what? OH. OH. Can you see that? The OH is a carbon number 2. So I can start from here. 1, 2, 3, 4. Can you see that? So at carbon number 2, I have what? OH. So here we have OH. Can you see that? So now that is they call the word 2 butanol. That is the OH is a carbon number what? 2, right? Now at carbon number 3, I have what? A phenyl group here. So there's a phenyl group here. We have a phenyl group here. Now, whenever a benzene is a substituent, it's called phenyl. So remember, benzene can either be like this, or it can be like this. It's okay, or it can also be like this. It's okay. So it's still the same thing here. So yeah, benzene is what is a substituent. So whenever a benzene, now the reason why it's called phenyl because benzene is what is a substituent. Do you understand? So now let's start placing our hydrogen here because I can number 3, I want a phenyl. I can number 2, I want OH here. Do you understand? So let's use what the hydrogen. So let's remove some here. So here we have what 2 hydrogen. 2 hydrogen. Here we have what hydrogen. Here we have hydrogen. Here we have what 3 hydrogen. This is that. Here we have what 3 what hydrogen. So now let's know the what amount of positive stereoisomers here. This guy is not a what? This guy is not a what? This guy is not a chiral center, right? Not a chiral carbon because this carbon have what 3 different groups, so it's not a chiral carbon. Likewise, on this one is not a chiral carbon. Do you understand? So these 2 are what chiral centers, chiral what carbon here, because this carbon have what OH, H, methyl, and all of this one here as one. Do you understand? So it's a chiral what carbon. This one here is having what H, phenyl, methyl, and all of this one as what as a group here. So it's a what chiral center. So here we have 2. So numbers of chiral center, numbers of chiral carbon. So you can say chiral carbon, which is N equals to what? 2. Positive stereoisomers, numbers of stereoisomers. Stereoisomers. It goes to what? 2 raised to what? N, which will go 2 raised to what? 2, which will go 2 or 4. Can you see that? So the next one to look at is what is C, right? Look at what the C part of this question. Look at what the C part of this question here. Look at what the C part of this question. You see that 3-chloro-1-butene. Here we have ENE. That is there's a double bond here. Just now, I can't remember. So here we have 1, 2, 3, 4. I did 1, 2, 3, 4. Can you see that? So that is the double bond because when you have ENE, it means what there's a what double is what is an alkene. Idea is a what is an alkene, and the alkene is a what is a carbon by what 2. So here we come here. No, it's a carbon by what 1 because here is what is 1. Can you see that? So going to be double bond is what is at this point here. Can you see that double bond at this point here? So here we have 1, 2, 3, 4. Idea. A carbon by 3 I have a chloro group. So here we have chloro here. So what we want to do here? So we'll remove what the number here, right? So next what to do now is to impute what your hydrogen atoms. This is going to have 2 hydrogen because carbon should have 4 bonds. Automatically here, because this double bond here, this carbon is already having 2 bonds. So it needs what 2 more bonds. So it's going to be 2 hydrogen. 1 2. Idea. Yeah, how many bonds is it having? It's having 3 bonds, right? How many bonds does it need? 1. So it's going to be what 1 here. Idea. Then we're going to have 1. You are going to have. Can you see that? So if I that this one is art, idea because you cannot get a chiral carbon when it's having a double bond because the molecule should have 4 different groups here, right? So these 2 are not chiral carbon here. So any double bond you see, any sp2 carbon you see is not a what cannot be a chiral carbon here. This cannot be a chiral carbon because this carbon already have 3 hydrogen. Why am I saying this one is a chiral what center? Because having what hydrogen, chlorine, methyl, and the whole of this one here. So this carbon atom is the only chiral carbon we have in this what molecule. 3-chloro-1 butene. Do you understand? So that is numbers of chiral carbon, which is what n is equal to what 1. I did numbers of isomers, numbers of what isomers, stereoisomers, number of stereoisomers, numbers of stereoisomers is equal to 2 raised to power n. Go to 2 raised to power 1, go to go 2. That is, this will only have 2 possible stereoisomers. Do you understand? So this has to identify possible. This has to identify numbers of chiral center, and that to calculate what possible stereoisomers. Do you understand? Now this is what we are to do in this class here. Now this class is a series class where I teach you on a constant what basis. Get so now the only thing I want to do for me here is like, subscribe if you have not done that, then comment if this video is helpful, because it's going a long way to tell me that you watching this video here and you're getting a lot of value from this video. So this is one of the class that will help you understand what's called possible stereoisomers. If this video is helpful, leave at the comment section that this video is what is helpful. So I'm going to give you one question. I want to give some question on the board so that you can try and leave your answer at the comment section. This is going to be your practice problem here. Identify the chiral carbon and possible stereoisomers. So here we have 3 phenol, 3 phenyl propanol. Here we have 3 chloro, 5 cyclobutyl, cyclohexanone. So go ahead and try this one for me. Leave your answer at the comment section. You get that? So I hope this video is helpful. Please leave it at the comment section if this video is helpful. I want to hear from you. See you in our next video.